All right, let's do problem number 2 of the Unit 5 practice final. And here's the worksheet. All right, here it says, Mr. Lakes, Tesla Model 3 accelerates from 0 to 60 in 5.1 seconds. They've actually improved it over the last year, but we'll just keep this. Assume the acceleration is constant. Convert 60 miles per hour to meters per second. And B, what is the acceleration in meters per second squared? And C, how far did the car go? So let's set this up with given, find, and solve. Given. Here's my Tesla. I don't think I can do. No, that's terrible. That's better. Here, oh. Looks more like a Prius. That's all right. Oh well. And it starts from rest, and then that's better. And then and then v equals 60 miles per hour at t equals 5.1 seconds. And it's also given that 1 mile per hour is equal to 0.447 meters per second. And what are we trying to find? Okay, A, we want the final velocity in meters per second. B, we want to know what is the acceleration. And C, we want to know how far the car went. That would be delta x. Okay. So then we solve. All right, so this is part A is pretty easy. It's just 60 miles per hour. Put that over 1. Now, 1 mile per hour is the same as going about a half a meter per second, or 0.447 meters per second. So that cancels that. And when you do the arithmetic, 60 times 0.447 equals 26.82. And we'll just, I'll just leave it like that. That's too many significant figures, but that's all right. Now part B, the acceleration. Well, B equals V naught plus AT. Or you can start with, A equals delta V over delta T. It'll give you the same thing. So let's solve for A. A equals V minus V naught, right? Subtract that to the other side, and then divide by time. So this is really delta V over delta T. 26.82 meters per second minus 0, starts from rest, and that took 5.1 seconds. So when you do the arithmetic now, divide by 2, and then times 5.1, you get 68.4 meters per second squared. Or meters per second every second, which is just as good. Now part C, I want to know delta x. Well, there's a couple ways to do it. I now know the acceleration. So I could use the third kinematic equation, but I think instead I'm going to use the fourth kinematic equation, or second kinematic equation. Delta x equals v plus v naught over 2 times time. That's the second kinematic equation. So v, what is v? V is 26.82 meters per second plus 0 divided by 2. Now this is my average velocity. Then I'm going to multiply that by 5.1 seconds. Oh, by the way, when I was grading your work, a couple of people did this. They wrote the equation down wrong. They wrote this as v minus v naught, but it's really v plus v naught for the second kinematic equation. Now, because v naught was 0, it didn't matter. So it didn't affect your answer. But if you want the average velocity, you have to add them together and divide by 2, not subtract them. So keep that in mind. So anyway, so I got 26.82 Plus 0 divided by 2. And then take that, multiply that by 5.1. And you get, wait a minute. Did I do something wrong here? Oh, you know what I'm sorry. I wrote down the answer for part C accidentally because I was looking at my, so how did I do that? Oh, okay, yeah, I just looked at the wrong thing. 26.82 divided by 5.1. There we go, 5.26, right? Hey, go ahead and yell at me if I screw up, especially when I'm recording. It's more fun to yell at me while I'm recording. All right, so 26.82 plus 0 divided by 2 times 5.1. 68.4. There we go. I don't know how I did that. Okay, so these are your 3 answers to the problem. And there's a problem very similar to this on the test. Any questions on this problem? Okay, that is all.